Xcode to do. That when you control click and drag in the other direction and then let go, the little gray pop-up window that we saw earlier, it's populated with a list of anything that was declared as IB outlets. What is it actually? Well, if you actually look at Apple's header files, it is just a type def for quote unquote. So it literally disappears when compiled down to that. So again, there's no functional change to the language. This is just an IDE trick to implement that drag and drop behavior. All right, so lastly, viewController.m. So most of this is just an implementation now of the stuff we just saw. I'm synthesizing all of my various properties up at top, just like we've been doing for a while. And now, just know for now that this clear message is going to be passed anytime the user hits the clear button. So it goes back to 0 like a normal calculator or ATM. Deposit is going to be called anytime the user clicks deposit after inputting some dollar amount. And then digit is going to get called when? Anytime the user touches one of the 10 digits, 0 through 9. Should auto rotate to interface orientation is only going to get called when the user twists the thing around, and I just left that as the default. It's only going to work in portrait mode. And then lastly, view did load. This was that stub earlier that I've been deleting, but this time I want to do something important. This time when the application loads and I can see the ATM's interface on the screen, that's the point at which I decided to create an account through alloc and init, and then I show myself by way of the show method. So in short, this is just the way of getting things started. And it's OK because I only have one view in this application. There's no flip side. There's no chance that this view is going to be unloaded in this part of the story. All right, so now let's look lastly at the nib. And let's just see what's going on. If I right-click on an arbitrary number, like 7, notice that a whole menu of possible events comes up. Did end on exit, editing did end, touch down, repeat, touch drag, enter. Notice the only one that I've wired up is touch up inside. This is the one that Xcode just presumptuously assumes you mean when you do the control click. Touch up inside literally means that. You touch, and then you go up, and then the event is fired. Why? Because you touched inside of that particular button. And you can sort of infer from most of their names what the other ones do. So this is saying that there is now a blue line from the touch up inside event to the file's owner's digit method. And again, who's the file's owner? What class? Who owns this nib? The view controller. So just to be clear, this is being passed now to an object of type view controller, and all of this stuff is empty. So if these are open circles, nothing's going on. You don't need to be visually distracted by anything, but realize that you don't have to just do the control click option. You can actually click and drag on these things to do the same thing more explicitly. So it's just another way of achieving the same result. Conversely, if I now look at the file's owner, I see different things. In fact, a whole bunch of things now. So outlets, I've apparently control clicked from left to right so that my balance label property, aka pointer, points to literally whatever that label is. Apparently it just has the $sign right now. Deposit label pointer points to this other label, which just says deposit right now. View I got for free just by using this initial template. And now these actions all refer to IB actions. Clear is going to be called on this object when I touch up inside the clear button. Deposit's going to be called when I touch up there. And digit's going to be called anytime I touch any of these available buttons. And that's just induced by the dragging and dropping. And if I accidentally screw up, suppose I accidentally delete 9, the 9 button will now not work in my application, but that's fine. I can just zoom out, control click from 9 over to file's owner, and remap it to digit. And that will put it back into the list. So that leaves one last file, this .m file's actual implementation, which we skimmed over a second ago. So why does clear work in the way it does? When I click clear, it's supposed to reset the UI to $0. So how does that work? First, I do self.amount gets 0, and that is, again, the local instance variable or property that's keeping track of the running amount in the screen. Self.show is going to call my own show method, which for now, it just cleans up the UI. Assume I factored out some code because I found myself copying and pasting a bunch of stuff. Deposit, meanwhile, does this. Self.account, this is my model, .balance, the model's balance property, gets incremented by self.amount, whatever the dollar amount there is. So to be clear, there's a duality here. Self.amount is the controller's own long that represents the current balance. It's not the string that appears in the view. I have my own copy of the raw number. Then I'm going to go ahead and clear self.amount and then reshow the UI. Why is this? Well, when you type in like 100 and then click deposit, I want to change the top part of the screen back to 0, but update the account balance in the ATM itself. And then lastly, digit is the only one that required a little thought as to how to do the math. So in digit, this is the method it's called anytime you hit 0 through 9. So I've apparently first cast the sender to a UI button. Why? Well, anytime you define an IB action, convention says to have it accept a pointer called sender to an ID. And I'm saying pointer, but you don't need the star if it's an ID. So you accept an argument of type ID. But if I actually want to do some button-specific stuff, I'm going to go ahead and cast it, sort of C style, to a UI button star. But I know that this is correct because I did the wiring myself. I know the only thing calling this method is going to be a button. Then I do self.amount, which is the total amount being displayed on the screen, equals self.amount times 10 plus b.tag. So b.tag, recall, is a special property on a button that I hard-coded. 7's button is 7, 8's button is 8, and this was just so that I had a machine-readable piece of data associated with each button. And what's the point of this times 10? What is that doing every time I type a digit into the UI? Yeah, it's effectively shifting the numbers over grade school style to the left by multiplying by 10. 10's place becomes 100s and so forth. And then lastly, the show method. This is, again, the code I just factored out. Anytime I want to update the UI, I now need to check what is the actual value in these long longs, and I need to convert those numbers to strings, and I'm going to go ahead and use these string convenience methods that we've played with a couple times. LLU is unsigned long, albeit reverse order there. And that's about it. So the end of result is that when I run this code, I get a little ATM-like interface that by default has 0 at the top. If I first type in 164, notice with each key press, I was calling the digit method, which was times 10, times 10, times 10, and adding the new value. And if I go ahead and click clear, it's going to call the clear method, and nothing happens. State gets restored. If I do it again and click deposit, this time I'm going to do the math and add it to balance. So balance on the bottom gets updated. Top gets cleared back to 0. But this, of course, is not perfect. If I do 5,000... sort of brings back memory of CS50 or whatever your first course was. So it's not perfect. We still have issues of overflow. None of that is hidden in Objective-C unless we use special wrapper classes. But indeed, the functionality now is all wired together. So what were the key takeaways here? So one, it's a much more involved application than that first one where we just displayed my name. But two, it also introduced a model, which is something you'll want to do for Project 2. And now we'll take a look at one last demo, which is just a utility application, which is the template from which you should begin. So I've created a new Xcode project, utility application. I'm going to go ahead and click OK. I'm going to go ahead and call this Project 2, even though we won't actually implement it. You'll see in the spec, we tell you exactly what to check here. I'm going to go ahead and click Next, save it wherever on my desktop for now. And now I get a default template that's mostly the same to the single view that we've been using, but there is a little more. What's the first thing that jumps out at you? Flip side. All right, so when in doubt as to what something does, let's just run it out of the box, see what happens. It should at least compile and run. So now I have my what's called main view. Doesn't do all that much, but notice the little eye icon. What's nice in this template is that out of the box, you already have an application that's more interesting than anything I've written thus far. All right, so how is this all working? Now, and just to paint a picture, the idea behind Evil Hangman is that when you run your program for the first time, you'll see the game's interface there. And we describe in the spec what it means to represent the interface. It doesn't have to be graphical. It can all be textual. But you'll have a button for new game and so forth. And then also a button for settings, much like this little eye icon, because you want to be able to control a couple of things. When you, in your project, click the settings icon, as represented here by this eye, you'll see the flip side view of the application. And there you're going to have two sliders, one of which specifies how many guesses the user should get when playing this game, and the other of which specifies the length of the word that you want to play with, whether it's 1 letter or 26 letters. And then there's going to be a third control, a toggle switch, that has the user turning evil on or off. And that will govern then the behavior of the actual application. I click Done. Control is returned to the main view controller. So let's see how this template is actually working so that you have a mental model for starting this particular project. So where to begin? Any such head dives? Well, I would always start with main.m just to make sure all is familiar. And indeed, It's copy-paste from everything else. Nothing very interesting going on there. In fact, under these other files, there are some things that might eventually be of interest. We mentioned this briefly 2 weeks ago, but a plist is a property list. This is just a fancy way of saying XML file. And you know what XML is? A property list is an XML file, but that Apple's Xcode happens to render with this nice little GUI-like interface. But this is an XML file being depicted as rows with data types. You can actually look at the XML file if you want with the text editor. Who cares? Well, we're going to give you a dictionary with, I think, 140,000 English words in the form of an XML file, much like Project Zero, but it's named words.plist so that you can drag it right into your project. Apple can then show you all of the words in this nice little user interface, which is mostly useless, but you'll at least see how it's rendered. But the upside of this is that now you'll have a chunk of data that gets burned into your application. You don't need to make any network calls or anything like that to actually access this data. And you can, if you want, particularly if more comfortable, massage it into some format like SQLite or Core Data or something else, but using a property list will suffice. For today's purposes, know that Apple provides methods in the SDK for reading property lists and iterating over property lists and also writing to them. So you can use property lists as fairly simple databases that are just lists of things or that are even places to store preferences. Indeed, the flip side of this Hangman application, when you change these settings, they have to be persistent so that if you quit the user, if the user backgrounds the application, quits the iPhone altogether, those settings need to be stored. And one of the simplest ways to store things is in XML files. You don't need to use SQL or similar. Yeah?
How does plist compare to like a database in performance?
Slower. How does it compare performance-wise? It's slower because it will be read serially from top to bottom. So with SQLite, Core Data, you'll get more optimizations. But I think you'll find that it's speed-wise, especially on gigahertz devices, 140,000 words is not a big deal. But there are more sophisticated models you could implement. Info plist.strings. This has to do with localization. If you want to support Spanish and French and Chinese and all sorts of different languages, you can factor that out. You're not required to do that for this project. And this PCH is, again, a precompiled header file that just gets automatically prepended to any of your header files. But you can also ignore this. So for the most part, you can ignore all of those files, but you will drag into supporting files per the spec this words.plist. We'll talk about unit tests in the future. I mentioned them briefly earlier, but also out of the box, if you check the right button, you'll get some unit tests or the beginnings thereof that you'll be expected to implement for the project a few weeks down the road. All right, app delegate. There is nothing interesting here. It's just template code we've looked at before. Appdelegate.m, nothing interesting here. It's just template code that we've looked at before. But notice, key here is that the default controller to whom the app delegate hands control is the main view controller. As its name implies, it's the main guy. He gets control first. All right, so let's look at mainviewcontroller.h. Thankfully, very uninteresting, except for one curious detail. What's interesting here? Almost all of this is identical to boilerplate thus far, but there's two additions. Take a guess. What words have you never seen before right now? Good. Flip side view controller delegate, and also show info. So Apple, some person at Apple, created this template so that you have a working starting point for this kind of utility application, which just means two sides to it. So flip side view controller delegate is apparently a protocol that's defined somewhere else that apparently this main view controller implements. As an aside, here's why that's about to exist. The main view controller, when you touch that eye icon, is going to instantiate a flip side view controller and then hand control of the application off to him, and then the screen spins. Once you click done on the flip side, that flip side controller somehow has to be able to hand control back to the main guy. So this delegate protocol is the signaling mechanism between main and flip that allows main to inform flip whom to return control back to. So very similar in spirit to the delegate thing I did with RJ's help for the dismissal of the UI alert view. So we'll see this delegate paradigm again. Show info, this is just the method that's called when you touch the eye icon on the screen. That's it. All right, in the M file of main view controller.m, what do we see here? Well, this stuff up here you can often delete. This is, again, a class extension, aka nameless category that Apple has been putting in their templates for some reason to encourage them, but it's a distraction for now, so I'm just going to erase it for now. Odds are you won't need it for this project. View did load, view did unload. These are skeletons, stubs rather, that we've seen before. This is a new thing. Anyone know what pragma mark is? Yeah, so a preprocessor directive. So this is a directive that's actually thrown away at compilation time, but what it creates for you, if you'd like to be very impressed, is this thing here. So in the IDE, notice you can jump around to different points in your code very easily. Why is that the case? It's because Apple included these pragma marks. So they're little like checkpoints just for UI simplicity. They have no functional relevance. All right, and flip side view to